This is the third of 3 videos where I'm talking about angles. First video, we talked about the key angle concepts of lines, parallel lines and their corresponding angles, vertical angles, supplementary angles. Second video, we talked about the interior angles of a polygon. Now we're going to talk about the exterior angles of a polygon. Now, if you remember from the last video, I talked about how when you have more sides of a polygon, the interior angles get bigger. So assuming these are all regular polygons, right? We kind of go, well, in a regular polygon in triangle terms is an equilateral triangle, 60, 60, 60, rectangle, 90, 90, 90. And then in a pentagon, it's 540, which is the sum of the interior angles of a polygon. If you don't know how to calculate that, make sure you watch that interior angles video. There's an easy way to do it, no formula required. 540 divided by 5 is 108 degrees. So you see the gradation, it goes up slower between 60 to 90 is a big jump. It goes up a little bit slower here from 4 to 5, but it does continue to get bigger, and that'll always be the case. An exterior angle is made by extending one of the, basically one of the sides, right? Not both, because if I extend both sides, all I've made is a vertical angle, right? But extending one of the sides. Extending one of the sides. It doesn't matter which. You can do it however you want. And all of these would be exterior angles. Exterior angles. Exterior angles essentially make a supplementary set of angles. Remember, supplementary angles add up to a straight line. A straight line's 180 degrees. And make a supplementary set with this interior angle here. Because I've made this straight line. Let's just break out this part of the triangle. We'll leave the rest of the triangle alone for a little bit. See what I mean? Whoa, make it a little bit more line-like. This plus this is 180 degrees. That's what I'm talking about. So something's got to give, right? As the sides go up from 30, or excuse me, from 60, it's a difference of 30. That's why I keep saying 30. From 60 to 90 to 108 to so on, so on, so on. As that keeps getting bigger on the inside, the exterior angles get smaller. So remember, these add up to 180. So 180 minus 60, well, that's going to be 120. And of course, this is regular, so all of these will be 120. All of these will be 120. 90, right? This is 90, 90, 90, 90, 90, 72, 72, 72, 72. Yeah, I'm missing one, 72. But let's look and see what happens. So let's add up the triangle's exterior angles. Well, 120 plus 120 plus 120, that's just 360. 90 plus 90 plus 90 plus 90, that almost looks like a 6. Let's do a little bit better. That's 362. 72 plus 72, 72 times 5, right? 72 plus 75 times. 72 times 5 is 360, right? So no matter how many sides you have, while that interior is getting bigger and bigger, going from 180 for a triangle, 360 for a four-sided shape, 540, 720 for a hexagon, 900 for a septagon, 1080 for an octagon. I think I went through that right. The exterior angles don't change. Why? Well, because it's like there's a circle around this. I'm going to try the best I can to draw this. We'll erase everything but our little triangle guy over there. All around this, just a circle. That's all that's going to cover is a circle. Boy, that's an ugly, ugly circle. But I hope you get the idea. So, as the exterior angles get bigger, or excuse me, as the interior angles get bigger, the exterior angles get smaller. And there's always two ways to get it. Now, if you have a regular polygon, like a triangle, right, an equilateral triangle, I can say, well, How big are the exterior angles? Well, since all the exterior angles will be the same size and they sum up to 360 degrees, each one will be 360 divided by the number of angles, 3, which one will be 120 degrees. I can do the same thing on and on and on. Only works with those regular polygons. Remember, regular polygons are polygons that have the same size interior angles. All of them are the same. So we're going to switch over to a full screen ACT problem, and we'll do that problem both ways. I think it's a nonagon. This is a reasonably common format for a exterior angles question. You got a nonagon, which is a shape a lot of you guys aren't going to be familiar with. It's a kind of a weird shape. You don't use it much. And they're asking you for the measure of the exterior angle here. So they don't really give you anything else on here to work with other than the ability to count the sides. But the fact that they drew this angle for you can actually let you solve the problem without doing anything. That angle is pretty small. It's clearly not even a right angle. It's clearly below that. So all of these other angles are just way too big, right? It's a pretty small angle here, that angle X. So it's got to be A. So that was really easy, right? Remember, don't hesitate to have that conversation. Make sure you have that conversation with your answer choices. Occasionally they'll get you a gimme like that. Now let's say that it wasn't such a gimme. How would you go about it? Well, let's go ahead and assume that you didn't know how many sides an nonagon had, which a lot of you do and a lot of you don't. I would count, and I would actually write down my numbers as I count, because if this was a different question and the answer choices were clustered closer together, there's a good chance if I miscount that question or miscount the number of sides, there's going to be a wrong answer choice for that. So there's a good chance I'll walk into a trap. Don't want to do that. So two ways to proceed. We're going to go the long way first. We're dealing with interior angles and finding the interior angle, then going to the exterior angle. And then we're going to go straight to the exterior angle. Okay, so what's the sum of these interior angles? Well, I could draw triangles here, or I could say, well, for every side over 3 sides, that's going to be an additional 180. So 6 times 180. Well, that's going to be 1080. 1080. Plus I got to add that original 180 I started with. That's going to be 1260. Remember, I had that extra 180 because I started at a triangle in my brain. That was a weird way to say that. All right, so 1260, and they tell me it's regular. Remember, regular means all the angles are the same size. So 1260 divided by the number of sides is the number of vertexes, the number of corners. 9, so that's going to be 9 goes into 12 once. That leaves me at 36. And that's going to go 140 degrees. Remember that the interior angle and this exterior angle here add up to 180. So 180 minus our interior angle will equal our exterior angle, which is 40. Okay, that's great. Kind of a long way around, but it works, right? How about the short way around? Well, short way around is you just remember no matter how many sides something has, the sum of its interior angles are 180 degrees. Or excuse me, 360 degrees. 360 degrees all the way around this thing. Go ahead and put my numbers back just for fun. So since the nonagon is regular, I know that that 360 degrees is split up evenly 9 ways. 360 divided by 9 is 40 degrees. A lot of ways to skin the cat on this one. Just make sure you have a way to calculate interior angles or exterior angles. By the way, didn't mention this in the last video. If you know the nonagon is regular, a sneaky way to calculate interior angles is using the exterior angle. So if I wanted to calculate the interior angle of this nonagon, I could say, well, all the exterior angles are 40, right? All these non-exterior angles are 40, and they're all supplementary to their respective interior angles. So that means they all add up to 180. Since this one is 40, it'd be 180 minus 40 is 140, and that would be my interior angles. That's one of the fun things, and sometimes it's one of the scary or confusing things about plane geometry. There's usually a lot of ways to get to the same place.